everyone, and welcome to another live session at the Reactors. My name is Rav, and I am the Program Manager at Reactor London. Before we begin, please take a moment to read Microsoft's Code of Conduct. We're all here to learn, so please be respectful of other people's views and be kind and considerate in the way you engage. Today is the third and final episode of how to use Azure to kickstart your DevOps lifecycle. And today's topic is infrastructure code. So I would just like to say, have your questions ready. This session will be led by Liam, who is a regional cloud advocate at Microsoft. Liam will also be talking about a cloud skills challenge towards the end of the presentation. So with that, I am now going to hand over to Liam.
Alrighty, thank you very much, Ralph. Hello, everybody. It is so good to be here again. Welcome to my third episode. What I'm going to do is I'm just going to get my screen shared, and we can get this up here. There you go, Ralph. You might need to put that on the screen for me, please. Thank you. Alrighty, so let's put that up. Wonderful. So welcome to my third episode. Today we're going to be talking about infrastructure as code. So what's on the agenda? On the agenda today, we have got a little bit about me, who I am, where I've come from, and what I do now. For those of you who haven't joined the past two episodes, it would be great if you go back and catch up, but this will certainly give you a bit of an insight as to who I am. Going to be talking about the series, going to recap on episode 1 and 2. So the first, the second and third week of February, first and second week, something like that. Introduction of infrastructure as code, and this is going to trip me up. It's a bit of a tongue twister going through these slides. Some challenges that you face with infrastructure as code, how you can get started as a developer, and the project that we're creating today. So let's jump into it. A little bit about myself. Who am I? Where do I come from? So my name is Liam Hampton. I'm a Microsoft Cloud Advocate based here in London, and I work with the Reactor team. So Ralph and James are my two counterparts here. I'm an open source contributor. I'm all about everything being open. I love software development. It's all about collaboration and keeping it secure and clean. Through that, I'm a Golang and Node.js software engineer. So prior to being an advocate, I did work at IBM as an engineer and an advocate as well. So I've done a lot of coding as a professional. Again, that was on an open source project. I'm also an Auth0 technical blogger through the Apollo program. So I do a lot of writing on sort of like IoT things, working with TinyGo, Golang, etc. And again, like I've got there, I'm an IoT enthusiast. I like to make things on Maker. I like to sort of code it and then see it working, essentially. And through that, I love public speaking. I like doing these kind of presentations and letting everybody know what's up, what's going on, and what I'm working on next. So let's have a little look about the series and what I've been going through. So there's two main takeaways that I want you as participants or screen watchers, everybody taking a look at this, to take away two things. One of them is to understand the DevOps lifecycle and the processes involved. And the second one is to put these learned lessons into practice. Whether you're just an individual coder, a developer, whether you're working in a larger team, just be fantastic to see if you can take some of this and apply it to your process. But particularly today, I would love if you could take away how to code some infrastructure and how to sort of go from working on a machine and seeing it happen in the portal without having to touch it with any mouse clicks. So in episode 1, we touched on the fundamentals of DevOps. We created a Go application and we deployed it to the cloud as an app service. In the second episode, which was last week, we introduced CI/CD. So we automated some of the deployment steps. So in episode 1, we were doing Docker build, Docker tag, Docker push, pushing the built image to a container registry. In the second episode, we automated that with GitHub Actions. And that was all around sort of removing that arduous task of having the developer to do that every time. You just write your code, push it to GitHub, and it will deploy automatically in the cloud. The third episode, which is today, we are talking about infrastructure as code. So we're going to be looking at automating some of the infrastructure creation. So there was one part of the infrastructure that we didn't manage to automate, and it's still very manual. We're going to automate that today. And finally, I'm going to be looking at a cloud skills challenge that I've created for you. So I've put together a bunch of Microsoft Learn modules, and we are going to be, I'm going to open it up, and it's going to be active from tomorrow. So yeah, today we are looking at episode 3. And of course, before I get into this, you can do this too. As a developer, as a hobbyist, as anything you like, you can do this too. You can write the code. I will make it all publicly available, and these links here will let you do it in Azure. So if you're a student, you can do aka.ms/A4S. And if you're a professional, you can do azure.microsoft.com/free. And what this does is it allows you to get a free account with Azure, and you get some credits as well. Not that any of this should really cost you anything at all, but it's still worthwhile because then you can play with other things, other services in Azure, should I say. So let's have a little recap of what we've been looking at over the past couple of weeks. We've written some code and we've put it in app service in Azure. And that app looks a little bit like this. It's a website. It's a travel portfolio that I've been creating with you. And this is actually going to be the start of a new website for me. I've got the domain and everything. So we're going to be working through this. And it's going to be a long project, should I say. So the way we did it was we wrote the Go code. Well, I kind of wrote the Go code prior to it, but it was there. I walked through it. We Dockerized it, creating a Docker container and a Docker image. We then pushed the image to Azure Container Registry, which is kind of like a private storage for containers, much like Docker Hub. Third, we created an Azure app service using the container. So we deployed the app service, and that was pulling the image from the Azure Container Registry. And then to automate some of the steps in the deployment, we used GitHub Actions to deploy code changes. So we didn't need to do anything manual there. We've looked at the 8 different stages of the DevOps lifecycle. This is kind of like an unofficial logo for it. It's an infinity loop. I did cover this in the first one, but it's an infinity loop because it doesn't stop. It should always be continuous. So we've looked at plan, we've looked at code, build, test, release, deploy, operate, and monitor. And we've had a little look at some of the technologies that are used in each stage. And as you can see, there's quite a few and it gets quite overwhelming, but we've kind of slimmed it down to a couple in this project. So I've cherry picked a number of them and we're just going to roll with them. Again, it is actually very much project specific. Please don't get me wrong there. I don't think I can use Maven with Go very much when I have Go build, when I build my binaries, for example, but very much tailor it to your project. Like I said, I've cherry picked a few for my own. So let's get into it. Let's look at infrastructure as code. Why is it so important to teams and enterprises and individuals? Well, it's all about speed. It's all about the time to market. Imagine if you're a developer and you have to continuously stand up servers. I mean, I've been there. You may have been there. I know a lot of other developers have, where we have sat waiting for so long, waiting for virtual machines to be spun up in the cloud, where we've been waiting for, container orchestration tools to be deployed and sort of bring things up and sort it all out and making subnets in networks and all sorts of things. Speed is important here because you're able to code it, which means you don't have to sit there and do a point and click. Very much let the code do it for you. And the cloud service provider allows these APIs for you to do that. Second is structure. Now, I talk quite a bit about structure in infrastructure as code. That sounds quite funny when you say that, but very much so, it keeps everything in place. So you can automatically see changes that are being made when you're making them in your code file. Whereas if somebody was to go in with the right access permissions in the cloud portal and start moving things around, maybe in the network or changing a subnet, a net mask or something like that, you wouldn't necessarily see it. So this is very much keeps everything in a formatted structure. Third, you have health. And this is kind of a bit of a wild one because people don't necessarily think about health when it comes to live applications and your infrastructure. Now, you want to keep everything up for as long as possible. You want to minimize your downtime. Now, with that, you can have it with some really hard, strict rules inside your coding files where you can see where everything's laid out in front of you. Whereas if you're in the portal, you have to do a point and click and make sure everything's tied and you're kind of switching context quite a bit. And that can cause confusion and ultimately cause downtime. So health is a very big important factor here. And of course, security. You want your network to be as secure, or your infrastructure, to be as secure as possible. There's lots of tools out there that help scan infrastructure as code files. Snyk is one of them. For those of you who don't know what Snyk is, it's very much a scanning tool. It'll help find vulnerabilities and issues. You have ones in Terraform. So Terraform will automatically tell you if your code will not compile using the right resource manager, so on and so forth. But security is very much right up there. So what is it? I keep talking about it. I keep saying it. infrastructure as code, but what actually is it? It is the automation of infrastructure provisioning. What do I mean by that? I mean something, well, actually, I've messed that up. That's the wrong slide. It's actually in the code stage. Developers might see that from the very beginning where they're coding it, and it's often in the deploy and operate stage, but where that should have been was after this. You're looking at web servers, you're looking at databases, and you're looking at load balancers. So everything that gets provisioned in the cloud. The common ones, you're looking at provision of virtual machines, container services. Those are very, very common. Like I said, if you're a developer, you don't really want to have to go through and stand up a bunch of virtual machines and wait for them to provision. I've been there, I've done that. I don't like it. It's not fun. So you want to do it as quickly as you can with some code. Creating users and IAM permissions. So access management, essentially with roles and privileges. It's very much a use case for that. That is a very arduous task to do manually. So you can do it with infrastructure as code in your files with the right resource management. And of course, installing software packages. So if you're provisioning a virtual machine, you may see something like user data when you're creating it. And that user data is essentially a script, which will go off and download a bunch of packages into your virtual machine as it's provisioning. It can either be done before it's stood up or once it's stood up. But again, that's just another topic altogether. And again, with manifest files, if you're using containers to bring in sort of third-party packages, all those kind of things. So very much you can do that within virtual infrastructure as code. How do you use it? Well, you're going to see this used twice in this presentation, declarative and imperative coding. Now, I'm going to circle back to exactly what they mean a bit later on. But generally speaking, when you create software or when you create a product, you will be looking at this, writing the source code. You will then be looking at how that is then sort of interpreted in the cloud. So an interpreter is used. An interpreter takes your source code that you've written and translates it into machine readable code so it can do its thing. And then finally, you have the deployed application at the end. So that is how a general application will be created. If you're looking at infrastructure as code, you'll write the IaC file. So infrastructure as code file. So this is just essentially the same. It's just a bunch of code which allows you to hit a service API. So I've mentioned about a resource manager a few times now, but the infrastructure as code will call resources with a service API. That will then allow you to stand up your application at the end. So it kind of goes hand in hand as to what you're doing with like manually setting up an application as to how it gets created, and then how you do it or the infrastructure with infrastructure as code files. Why do we use it? We use it so we can reuse the code. That is very much the point of infrastructure as code, or one of the main points of it, shall I say. As you can see here, a script at the bottom can create the development environment. It can also create the pre-prod or your test environment. And it can also create your production environment, but they are all the same. These are identical environments, and they're brilliant for many reasons, because if you're in development and you want to be testing features, that's brilliant, but you might not necessarily have any of the load that a production environment might be able to give you. So if you were to deploy the same environment in production and have sort of people live testing it, you can test live loads. And the same as in test, you can have multiple people in your organization testing your application, your code changes, and seeing how the infrastructure underneath everything is running and coping with it. You may need to scale up more. So in development, you may think you might need one load balancer to scale to maybe like 2 or 3 nodes. But in production, you're finding that load balancer maybe needs to be a bit higher. You may need 5, 6, or 7 nodes. So you can sort of adjust it accordingly. And with an identical environment, that's more obvious to see. Secondly, we got deployments. If you remember from the first episode that I ran, I spoke about different deployment methods. So you've got things like blue-green deployments, you've got canary deployments, you've got shadow deployments, all those kind of things. Infrastructure as code helps make that more possible, quicker, more testable. So we've established that we can create identical environments. So we've got a development environment and we've got a production environment. How about we don't call them development and production? How about we take those environments and label one version 1 and the other one version 2? That will allow us to do blue-green deployment. We can have identical environments with different, different code on top of or inside your application, but the underlying infrastructure stays the same. So when we are deploying it, you can deploy version 1 and have 90% of the traffic go into that one. And then you can deploy version 2 along the side of it and have 10% of your traffic going towards it. And then over time, you slowly transition to version 2 having more traffic. But this makes it really easy for you to spin up an identical environment that's already in production to do it again with your new code changes. Just the same infrastructure underneath. Ultimately makes it testable, right? So in a production environment, like I just said, you can test it much better, much quicker, much faster if you've got multiple of them, and it's very fast to stand up. What are some of the challenges that you face with infrastructure as code? And this is kind of an odd question because some may call it issues. I've called it challenges because they're very much, less of an issue, more of a challenge, which you can adhere to, you can avoid them, and very much you can sort of amend them. One of them is config drift. Now, this is my favorite example. That is actually a laser beam, right? So config drift is where you make really small changes at a time. So you might make one minute change, deploy it. And then the next iteration, you might make another minute change and then deploy it and so forth. That's all good if you're planning to make the changes and you need the changes. But if you're just suddenly got like a main configuration aim that you're just trying to stick to with like the core backbone of your infrastructure, and then you start making changes over time, that core backbone is now shifting. So if you make a small change, let's say, I don't know, a small subnet change or some network traffic or something, you're not going to notice the difference straight away. However, over the long run, that distance is going to get greater and greater. So a really good example is this laser beam. If you make a small change by maybe moving it 1 or 2 degrees to the right, you're then going to see, well, not a lot at the beginning, but over a long extended period of time, that laser beam is going to get further and further away. So that's how it kind of looks with config drift. You're going to get duplication of errors, or duplication errors, should I say. When you're trying to deploy infrastructure as code, if you've already got a server that's named ABC and you try and deploy another one that's called ABC, you're going to get a conflict. Now, you're obviously going to get told that by your tool, but then if you then decide to name it XYZ, well, then you've got 2 load balancers doing the same thing, and you're going to get duplication of infrastructure. And you don't want that. It's going to cost time. It's going to cost money. You have to amend it. You want to eradicate that by having good testing in place to begin with to ensure that it's not already be created in your environment. Now, a lot of tools do that for you, but there are some where you've got to be a little bit more careful. Thirdly, it's a skill. You've got to have a foundation knowledge of what's going on in the cloud. You can't just expect any developer to start creating infrastructure as code files and sort of scripts without having a real basic understanding of cloud and cloud infrastructure and kind of the services available to you, because not all tools are going to give you every single API available that you may think is available. And there's a really good use case of this, which I will show you in this presentation, or should I say in my demo in a minute, because I ran into this issue a few days ago, and it's a good one, I promise. And then finally, you're handing over control. Now, this is the bit which I don't like as much as a developer, because I like to have my finger on the button all the time. I like to know what's going on, when it's going on, and how I can interact with that. Now, when you're creating these scripts and these files, you're putting your thoughts onto a piece of paper as such, and letting everything else be handled by the cloud service provider. You're not going through the portal, clicking buttons and, oh, maybe I can read that information button. It might give me a bit of extra description as to what this service actually does and what it is. You're going to be reading the documentation, and it's going to be verbose. It's going to be full on. So you've got to have an understanding of really what's going on in the cloud, how you can convert that onto a piece of paper, and still have an understanding of where it's going and what you're trying to achieve. So how can you get started with all of this? I've mentioned quite a lot of things. I've said, whistled over it quite quickly, but how can you get started? Now, this is where I loop straight back to declarative versus imperative coding. Now, there's a big difference between them, but all tools are kind of very similar. So imperative coding is, the best way to describe it is organized code of how we as humans might perceive it and think. So you've got a lot of more control in imperative coding. You're going to have things maybe like if statements and that kind of thing. It's very detailed. It's very much like a script. And like I said, how we think, as in we're going to need to do task number 1 before we do task number 2. Task number 2 needs to complete before we do task number 3, and so forth. Very, very procedural in that respect. And a really good example of that is Chef. I've used Chef a couple of times. It's a brilliant tool, very much edges on the imperative side of coding or infrastructure as code. And secondly, we have declarative. Now, this is where you define your end goal of the system and any attributes that it may have. Now, spoiler, we're going to be using declarative tool today. And what it basically means is you're going to assign A to a value of ABC and B to a value of XYZ. And what that's going to do is that just it's very much like JSON. So it allows you to see what's going on very, very early on. So you're going to say name is equal to Liam, surname is equal to Hampton, and so forth. Very much declarative. You're giving it essentially key value pairs. Some tools here. We've got Terraform, we have Bicep, we have Ansible. And Ansible is kind of a queried one because it does allow you to do some imperative coding. Well, there's some imperative coding features in there, but very much declarative. Other ones, we've got AWS CloudFormation, we've got Puppet, we have SaltStack. There's loads of tools out there. And declarative is very much a newer version of infrastructure as code. It's more of that's where everybody seems to be shifting to at the moment in tech. So let's have a little whiz of the project. So we've already recapped on it, but go one more time. We've put some code into an app service, which has given us a website, which looks like this. And as I said earlier, there's one part that we haven't automated, and it is this lovely part here. It is the app service. We had to go into the cloud portal and create it by hand. Arduous, quite boring, not very fun, but you can see what was going on. Let's put that into a code file. We are going to use Terraform. Terraform is a really, really popular infrastructure as code tool. It's declarative. It's very fun to play with, very intuitive, and we're going to be using it today. So what we're going to do is we're going to write a script which creates an app service plan and an app service for us alongside what we already have in the cloud. What that's then going to allow us to do is pull the container from the container registry, which we threw up there last week after making a few changes. And it's going to pull it from there, and it's going to create this app service, which will be essentially our website again. What we don't need to do is create a new resource group or a container registry, although you can. But the reason I'm not is because I've already created them. And the way we can think about this is, say, the container registry doesn't need to be in Azure. It can be in Docker Hub. It could be in Quay. It could be in any of the other registries that hold containers. We don't need to make that again because we already have one. We don't need a resource group again because we already have one. All of our resources are already under a resource group. But what we can recreate is the app service plan and the app service. So we're going to go and do it. And the way we're going to do it is we're going to write a Terraform file. We're going to do Terraform init, which will initialize the Terraform builder on our machine and make sure, save the state, everything like that on our host machine here. I'm then going to do Terraform plan, which will then say, it will run through the infrastructure as code file that I've written, and it'll say, yes, we can create this, or no, you have some errors. It's basically a checker, kind of a linter in that sense, and it will get it ready for deployment. And then we'll do Terraform apply, and Terraform apply will then go off and call the service APIs that we're expecting to create our services, and it will hopefully spin it up in the cloud. Now, this did fail about 45 minutes ago, but we're going to try it again, and otherwise it'll be a good, fun debugging session. So with that being said, how are we doing for time? Cool. So it's only 25 past, so we've got plenty of time. Whilst I set this up, Rab, is there a question or two? Oh, I don't think she's there.
Oh, sorry.
Okay.
I was on mute.
There you are.
I was on mute and I was talking. I was there. We have lots of questions. Can I just read out a couple to you?
Yep, do one or two, and then we can crack on.
So is Azure GDPR compatible in Europe?
That is a really good question, and I would probably refer to the docs for that one. I can grab out a link for you if I make a note of that one. I will get back afterwards.
Okie dokes. The second question is regarding the Azure Databox service. Once Azure Databox is shipped back to Azure for data migration project, what happens to data differences, the one which is not migrated yet on-prem, until Azure Databox transfer data to Azure storage?
That is a very good question. Any changes are going to be stored. So they'll always be visible as far as I'm aware. I hope that kind of answers your question. I know that's quite a full-on question. Probably something to get into maybe at the end of the stream.
Okie dokes. Do you want to take another question, or you?
I will crack on with that one. I've just made some notes for that, and I'll get back to you.
Okay.
Alrighty, so we get back into the stream. So if I look into the cloud portal, which is the resource group that we have created last week, well, 2 weeks ago, if I make this one full screen. Can you see that all right? That looks like it's okay. We can see on here, we've got the app service plan, we have got the container registry, and we have got the website that I deployed with a webhook. Now, the webhook allowed us to update the website every single time a new container was pushed to the registry. And that was being pushed through the GitHub Actions pipeline, which of course was kicked off when you made a code change. However, what I've done here is I have turned off this website. So if I try and browse, you can see it's here, it's stopped. If I try and browse to it, oh dear, we can't get there because it's stopped. That's fine, because what we're going to do is we are going to deploy another app service and another app into this resource group so that we can see what's going on with it. So we can just see it create with some code. Now, for some background context, for those that were not here last week or the week before, I'll just quickly whiz through what we have got down here. So if I find, I don't think I've got it open. Maybe it's that one. Yes, here we go. So we have got a main.go file, which is a pretty simple, straightforward server, and it's going to render like the website page that I showed in the PowerPoint presentation. It's going to pull up a main HBS, so .hbs is handlebars. You may have commonly seen that with JavaScript, but we're going to be using it, if I zoom in actually. So we're going to be using it here in Go because I'm using a server called Fiber, and Fiber is a server very, very similar to Node Express, just for some context. And it's pulling in a header, embedded, and a footer. Now, all the embedded means is it's going to be pulling in the index.hbs template file in the directory that we're currently in, which is over here in views. And it's just got a couple of sections with the descriptions that are being pulled through, a title and a bit of styling, etc. The first week we created a Docker file, and it was a multi-stage Docker file. So we had the first one, which was Golang 1.17.6, keeping it consistent with my current local machine. Use that as build. And that just meant that we're just using the first file as a build file. Otherwise, this end image would be huge. It'd be about 1 gigabyte. Once we had finished building our assets, I then created another image and copied everything that I needed, the views folder and the website binary at the end of the build, into an Alpine image, 3.15, again, keeping it consistent with the one above. And that meant the image was about 14 megabytes, which just meant it was lightning quick to spin up and deploy. Talking about deployments, last week we created the the GitHub Action deployment pipeline, which, like I said, did some tests. It logged into the container registry, was able to build the image and then push to the container registry. So we had a new container in Azure every time we made a code change. So on today's episode, we're going to be building a Terraform script, which will go off and build the app service for us. So what I'm going to do is I'm actually going to come out of this. I'm not going to do this inside my inside the root directory, because you wouldn't necessarily have Terraform scripts inside the root code directory. You would usually have it outside in a different folder, still version controlled, just somewhere else. So what we're going to do is if I clear that one, if I do a pwd, I can see here I'm in DevOps Series 1 script. I'm going to create a new script. So in here, I haven't got anything, but if I do a touch, so this is just how I create a new file. So touch, and let's just say script ep3.tf, and .tf means it's Terraform. It's just the extension for a Terraform file. And let's go and open that up in VS Code. Let's wait for that to spin up. Okay, so we have nothing in this directory besides one Terraform file, and it's empty. So in the interest of time, I'm going to copy and paste chunks of code, which I've kind of got in a different script to build this. But again, I will explain everything as I go. So the very first thing we want to do is instantiate Terraform. So what we're going to do is going to drop in a block called Terraform. And this is going to say, I'm requiring the Azure Resource Manager, and the source is HashiCorp/Azure RM. And what that means is it's going to pull it in. It is all open source. It's all on GitHub. You can access it, create tickets, and add code if you like. But we're going to be using this one, the Azure Resource Manager. Second to that, hopefully you can see that. Actually, I'll zoom in a little bit more. Yeah, there we go. Okay, so the next block that we're going to want to do is we want to initialize the provider. And what that means is telling it we are going to be calling these APIs. So we've already said we want to use it, but now we have to initialize it. We have to say this provider is in here. And this way you put extra features. So if you want to do, I don't even really know what goes in now. I've never used it, but extra features for the Azure Resource Manager APIs, you would put them in here. Now, thinking about what we want to be doing, we're going to be logging into a container registry at some point to pull the image. So we are going to want some variables. Now, these variables, we want the username and password. So if I drop in the CR username and the CR pass, let's actually close that one down because we don't really care for that one at the moment. So variable CR user and CR pass, it's container registry username, container registry password, and we're going to give them a type of string. And that's just telling Terraform that this is going to be inside quotes. It's just going to be a string of, well, a data type of string, essentially. After that one, we're going to think about naming. So when I name this app service, I kind of touched on it in the presentation, but you want it to be unique every time. Now, there's a way you can do that, and there are some predefined ways in Terraform that you can do it. And one of them is just by saying random UUID. And I've just called it unique identifier in this instance. And all this is going to say is every time I call this block, there's nothing in it, but every time I call it, it's just going to return a random number for me, a random unique identifier. So that then leads us to our resources. So we've got all our predefined bits and bobs. So we've got the variables, we've got the random unique identifier, we have got the definition for the Azure Resource Manager. We now want to create an app service plan. Now, if I drop this one in, so this is quite a big block, but I will go through it. So let me just make sure there's plenty of space on the screen. Okay, so let's talk through this. Resource, we're calling the Azure Resource Manager App Service Plan API, and we are calling it App Service Plan just locally. So this is how I refer to it if I ever wanted to get something out. Now, I've left these two comments in here because if we're going to be creating a resource group, we don't need to, but if we did, we could access the location of it. So anything that's predefined above or in a different block, we can access. But let's take those out for now. I just wanted to leave them in there to show you. I have actually named it UK South. So I have called the name Liam Hampton DevOps App Service Plan. And that's because that's unique to me. I know that's unique. I could put a random UUID on it, but I don't want to. For this one, I want to show you that in a different block. We have the location, which is UK South. Again, keeping consistent where all of my other resources are. You can have this wherever you like, but it's all dependent upon cost, where you are, what's best, and what suits, because not every resource is available in every location, remember that one. The resource group name, which is Liam DevOps Series. Now, I have got that from my resource group name in the cloud. So if you remember, I created a resource group. I named it Liam DevOps Series. So if I was to have a quick look in here. So in here, we've got resource group Liam DevOps Series. What else we got? We have got the kind, which is Linux. And this is going to tell it that we want this to be, or what's going to run on this app service plan is a Linux machine. And we have to say it's reserved as true. Now, I'll come back to this and why afterwards, because it makes sense with the other blocks once I've put them in. The SKU, if you remember when I did the last one, I think I chose basic. But because of what I want to do and where I want to go forward, so forward planning, I'm actually going to create a standard one and I'm going to give it the size of an S1. So it's only a small standard tier, really, really cheap. I think if I was to do this in the portal, it might come up at like $9 a month. But for what I'm going to use, it's not going to be anywhere near as much. It will be a couple of pence, I think, at best for me. Like I said, if you're going to run it for the whole month and have it absolutely bombarded with traffic, that might cost you more money. But for me, this is perfectly fine. And I don't need it to be any more than that. So we have an app service plan. When we have an app service plan, we want to create an app service. So the next block is super big. So we're going to do this in chunks. So we're going to create an app service. So here we go. So this is the start of it. So this is the first bit. We are going to give it, again, the name of the resource. When we're calling the API, it's called app service. We're going to name it app service locally. So whenever I reference this locally in this file, I'm just going to call app service dot if I want anything from it. And here's a really, really good example of using that dot notation. So with the unique identifier, we have called the random UUID unique identifier. So we've called the resource itself, which is up here, random UUID. And we've called this block, which is unique identifier, which we can see here. And then we're just going to get the result. Now, I know for a fact this returns a result, but it's very much the same when you're writing JSON in JavaScript or going through any kind of sort of lists in that sense. I know it returns as a result, so I'm going to give it .result at the end, and I'm just going to do -Liam's world website. So this means every single time this script is run, a new application will be spun up with a random unique identifier before the actual name. And I'll come back to why in a moment. Again, we've called the location UK South, keeping it consistent. I could use the same dot notation as above, but I just want to keep it simple for this episode. The resource group that it's going to be under is, again, Liam DevOps series. And the app service plan ID, these are all required. By the way, I forgot to mention, these are all required for Terraform to be able to create this resource. And I'm just going to be calling the ID. So I'm going to give the app service plan ID, and I'm going to call it the ID of the app service plan. It kind of sounds a bit odd saying that, but yes, that's what I'm doing. I'm grabbing the ID from the one above. Next, you want to look at the site configuration. So every single time when we went through the app service creation in the portal, there was like a whole bunch of lists and ticks and boxes and typing that I had to do to be able to set it up with names, where you want it, what kind of machine it's going to run. Is it going to be a Docker container? Is it going to be a Git repo? This is where we specify all those site configurations. Because our app service plan is is of Linux type, we need to give it the Linux FX version, which is the Linux box that we want to run this on. And again, this all ties back to when we were building our binary for the Linux version. We were building the container for a Linux box, keeping it consistent. And this is where I put Docker, and this is where I'm going to call it the container registry and the image. So as we can see here, it's Docker DevOps on Azure.azurecr.io/DOA. So DevOps on Azure, episode 1, version 1. So that was the first image we made, and it's version 1. And I'm going to say always on is false. So by default, I think it actually goes to true, but we don't always want this box to be on. We want it to shut down after a period of inactivity. So now we've done the site configuration of what that's actually going to be doing. We need to put in some app settings. So we've specified that we want the Docker engine or the Docker daemon to run and pull this image from this registry, but we need to say how. So we're going to add some app settings. So this is very much what you'd see in the portal. And again, I've left this in here because I'm going to come straight back to that at the end. But if you went into the app portal and we looked at the app itself, if I just quickly whiz through here, we can look at the configuration, I think it is. It's one of these, deployment central configuration. Here we go, yeah. So we can see here, we've got the name and the value. So Docker enable CI, we've got the registry server password, the URL, username, and the website storage. So we're very much specifying these variables at this point in the code. So like you see here, app settings, just like I've just run through on the website here, but I'm using something different. I'm using a variable because the last thing you want to do is commit API keys and credentials. I don't mind if my server URL goes in somewhere. That could be hard-coded, taken out. It doesn't bother. But it does bother me if my username and password are in Git. You don't want that in version control, so you want to abstract it. We're going to be taking it out, and we're going to use an environment variable. And I'll show you how that runs as well in a second when we run it. Lastly, for it, to close this block off, we need to say the identity is a system assigned. So what this actually means is Azure is going to generate the service principals for us. This is all to do with access and roles to the application itself, but we're just going to say, hey, I've got nobody else in here. I don't have any role set up. For me, I'm just an admin. I'm going to let you do this for me. You assign it. You just let me access it. And people around, going to let it handle all of that for me. So system assigned is the identity. And that is actually all of the code. that we need to create an app service and an app service plan. Now, of course, there's ways you can abstract all of this data and have it pull from many different ways, like I've tried to show you with this one here, so random UUID. You can do a lot of this from previous blocks, so a lot of capturing data from returns of other blocks in different places. Now, a really interesting one is here, Docker enable CI. Now, I'll show you a pull request, which is actually going to allow me to do this, but let's go and deploy this first. Okay, so let's save this file. Let's open up a new terminal. And the 3 commands, if you remember, that I had to write were Terraform init, That's going to initialize this directory as a Terraform directory. It's going to grab the state. It's going to do a bunch of things, find the plugins, get the version, all that kind of stuff, all the goodness that we need to be able to deploy this. Awesome, it's successfully initialized. The last thing that the second thing I need to do is a Terraform plan. And what that's going to do is it's going to make sure that I can do everything that I want to do. It's going to ask me for my environment variables. Now, you can grab this from your shell. So you can do an export and export the environment variable to your shell, and of which we will do that in a moment. But for this, and for anybody watching, I will be changing these credentials straight after the stream. So for the password, we're going to pop that one in. And for the username, we're going to put DevOps on Azure. So that's the username and password of my container registry. And all it's going to do is going to make sure that I can actually create these in the cloud. So give that a moment. It'll probably take a minute or two. What else? Yeah, that's all it's going to be doing. Cool. So that passed. It means it said, you know what, Liam, yes, you can go ahead and create this if you want to. And because I didn't put any other options, it hasn't gone ahead and applied it. But if we wanted to, we can export. Now, if we want to export something, we have to do it with a TF var. And what that means is if I just run this command here, so if I was to export it to my shell, so export TF _ var _ CR pass and give it that one, export it to my shell, and the same for a username. Hopefully it won't ask me to do that again when I apply it. So the last command that I need to go ahead and do is Terraform apply. And this is what may take a moment. But if you notice on the left-hand side, we've got like a whole bunch of files that are popping up and have started, been created. And what that's doing is just creating the state locally. So you wouldn't ever want to do this or commit half of these to Git because it's local state and you might have some variables in there. And of course, it's going to ask me if I want to really go ahead and do this. And I'm going to click yes. So as you can see, it gives you like a proper output, like a full run output of what it's running when it's running it. So it's already created the unique identifier, which is this long number here with a few letters in, creating the app service plan. And it's still creating it. And this might actually take about 30 seconds to create, because if you remember, this wasn't actually quick in the portal either. But again, this is just grabbing or calling a bunch of APIs, which will create this service in the cloud. Now, if you did notice, it didn't ask me for the credentials again, because I saved them to my shell and I was able to pull them out from the shell when I run it. But again, otherwise it would just, it will just ask you for it, prompt you for it. Great for pipelines because you can add it as an environment variable, but also perfectly good for your local environment too. Fantastic. That has created it. That's created it's created the two resources that we wanted. And of course, it created the unique identifier. So if we were to go to my cloud account, and if we go back to the resource in here in the resource group and we refresh it, we have got a few other things. We have got the Liam Hampton DevOps app service plan. So we got a new service plan on the standard S1 tier, or SKU, if you want to call it that. We have got a unique identifier with Liam's World website. Brilliant. If we look in here, we can open this up. And hopefully, if we click browse, it might take a moment or two because it's got to pull the image, but this should work. In fact, it will work because it's deployed it. So one or two of you may have noticed something, and you may have noticed something pretty detrimental here. We haven't created a webhook. And it's not because I'm going to use the existing webhook. It's actually because Terraform doesn't allow me to. Now, I can show you the code in a moment, and I will actually drop it into the file, but I won't be able to run it. It's just going to have to stay commented out, or I could show you the Azure documentation. But it won't allow me to do that because the API simply doesn't allow an exportation of the webhook URL. But we'll wait for this to spin up, and I'll show you what I mean in a moment. And I can see the chat is going off. Cool. So, okay, demo of GitHub repos, please. What do you mean by demo of GitHub repos, Banu? But your username is always root, so why have it as a variable? That is a really good question. I like to completely abstract all personal information away from any scripts that I write, whether it's a username or a password, because again, oh no, it failed. Of course it failed. What happened here? Okay, I told you this failed just before this demo, but it's fine. I got too complacent. I said it was going to work and it didn't. Okay, so let's have a little look. Might just be taking time to come up, you know. Give it another shot. What I mean by webhooks is, there we go. It just took a little bit of time to come up. Phew, that scared me. But cool, we actually have the website here, and I can go through it. And again, it's just, it's deployed everything we wanted. We can see from the URL that it has deployed the one that we want. It's up and running. This is the unique identifier. Now, when I was talking about the webhook, what I meant was this one down here, continuous deployment. Now, in the script, if I was to have continuous deployment on, so let's close this a minute. So this one here will allow me to turn that little checkbox on and off. But Terraform doesn't allow you to get the webhook URL out of the app service yet. And I know it doesn't because it took me a while to find it, but there is actually an open pull request which fixes it. So at the end of it, all we would do, so you can pull out the source control, you can pull out a whole bunch of things from the app service, but webhook URL is not one of them yet. This pull request here, so I'm calling out Terraform, doesn't allow you to, but as of next week, hopefully when this gets merged in, it will work with the webhook. So that is actually the demo over. So this is just proving that we can create services in Azure with Terraform, and sort of how you go about it with a bit of code. I will make sure all of this is actually in GitHub. So I will ensure all of this is up there and available for you. So what I'm going to do now is jump back to my slides, and let's just go back into this one. So a quick series recap. What have we done? So the episode 1, we wrote some code, we Dockerized it, we pushed that image to the container registry, and from there we were able to create an app service which pulled the container from the container registry and deployed it into Azure. The second episode, we automated a pipeline. So you could just write some code, push it to GitHub, and it dealt with the rest. And then finally, we've been able to code an app service code a Terraform script to create an app service, which will allow us to pull the container from a registry. And like I said, this registry can be anywhere. It's just up to you in your script how you grab it from, or what container registry you get it from with the credentials. Ultimately resulting in a website. And now let's move on to the Cloud Skills Challenge that I've created for everybody. So what is it? What's the Cloud Skills Challenge? Now, Cloud Skills Challenge is something which it's like a series of Microsoft Learn modules of which you'll go through and complete each one of them. And then at the end, you get like a little trophy saying, well done, you completed it. Now, in this Cloud Skills Challenge, what I've done is I've put together a whole bunch of Azure material. So everything which I've gone through, so deploying containerized web apps to app service, we've got the container registry, so how that really works, what it is, sort of really starting from the ground. Deploying from GitHub Actions into Azure. So that'll give you a feel of what it's like to create a pipeline. And you can see it just peeking off the bottom there, but implement Terraform. Again, being able to write these scripts and interact with Azure Resource Manager and be able to pull up those resources. And there is one more on there, and it's actually the Azure DevOps introduction, which will give you a full scope of agile methodologies, what DevOps is, sort of how it can help achieve a better team, a more efficient team development environment for you, and so on and so forth. There's quite a bit to do. They're not long. They're pretty short modules. As you can see, it's like half an hour, 40 minutes, an hour. I think the Terraform one's actually quite short as well. I think it's like 25 minutes. Please do give it a go. And if you do, we've got 50% off AZ900 certification vouchers. Again, the Cloud Skills Challenge is at the bottom here. So it's aka.ms/DevOps LDN CSC. So a lot of acronyms there, well, abbreviations. I love to do that. So Ralph, if you could, please can you pop that one into the chat so everybody can have a link. This is going to be a first come, first serve for the completion of it and the certification codes. I'm going to say the first 50 will be able to get a code. And this is going to run from tomorrow. So I think it's midnight on the 23rd, all the way through to the final day of March, so the 31st of March. You've got plenty of time to complete this. And yeah, so please do go ahead. I would love it if more people can get certified on Azure. It's a really good certification to do. I've got a number of certifications, and it really, really helps with your, not just your learning, but in a professional environment as well. It's kind of like, you know, cloud, you've done something to certify yourself. I think it's always really good when people do that. Secondly, how you get the voucher. Obviously, I am not allowed to reach out to you. It has to come from you because of data. I don't capture any data when you go through my Cloud Skills Challenge. I don't see it. I'm not allowed. So I would love it if you could reach out to me. It's step number one. Reach out on Twitter or LinkedIn. Tell me you completed it, and I'll give you like a really good emoji back. And then the second one is to prove that you've done it just by sending me your profile link so I can kind of see what you've completed on there. Or a screenshot of the completion with like the little trophy thing that you get. And then I'll send over the code to you. If you want the DevOps series, the code that I've been creating today, last week and the week before, it is going to be in my GitHub. So again, it's the same as my Twitter handle at the bottom left. It is aka.ms/LDN DevOps Series 1. And my handle is Liam C. Hampton. So yeah, please do go ahead and grab it, play with it. I'll make sure it's all documented. I'll make sure Terraform script is in the same repository so you can give all of this a go, and you can use all of your credentials and store up all of your things. Like I said, it's free. Give it a go. Yeah, and especially if you have credits, again, it won't even matter. Awesome. Thank you ever so much. This has been a fantastic series, and I've really, really enjoyed creating this material for you. Again, if you'd love to, or if you'd like to find more events like this one, please join our Microsoft Reactor London meetup group. Alternatively, you can catch me on LinkedIn at Liam Conroy Hampton or Twitter and GitHub at Liam C. Hampton. With that, I'm going to hand it back over to Rav because I think she's got a few things to go through with you all.
Thanks, Liam. Would you have a bit of time to answer a few questions?
I do, yes. Because I can imagine there's quite a few. This is a hot topic.
Yeah. Just going through the chats. Obviously,
so I've got a few. I think one of them's on Databox and the other one is on Azure, something or other. If I grab that up as well, I'll go through it.
Yeah, so that is regarding the Azure Databox service. Once Azure Databox is shipped back to Azure for data migration project, what happens to data differences on prem until Azure Databox transfer data to Azure storage?
Okay, if it's all version controlled, which I would presume it all is, you'll still be able to find the differences. Alternatively, if you reach out to me, I can put you in contact with somebody that actually works on the product or a team or an architect or a consultant in that domain. That would probably be better. I'd rather you get the right answer than me try and fluff one for you.
Awesome. And then our next question is from Jeff.
Hello, Jeff.
I've heard Ansible talked about as a declarative tool where imperative Terraform is using for infrastructure deployment and declarative Ansible used more for configuration management. Is that correct?
Can you pop that up on the screen? Because that was a lot to take in. This is the fun bit about infrastructure as code, because declarative and imperative, there's a big difference, but it's also quite a slight difference. Okay, so you said, I've heard Ansible talked about as a declarative tool. Very much true. That is true, that part. Where imperative Terraform is using infrastructure deployment. Terraform is actually regarded as declarative because, like I just showed you in the demo, it is very much A equals ABC, B equals XYZ. So Terraform is declarative. So you said for using infrastructure deployment and declarative, Ansible used more for config management. That is actually correct, yes, because Ansible does cater for both. Ansible is quite a big project coming from Red Hat, and yeah, Ansible kind of caters for both of them. Ansible is declarative, but it also does have imperative features in it. Terraform is very much declarative in that sense. Hopefully that answers your question. That's a good one. I like it, Jeff. Thank you.
Great. That's it, I think. We just had a lot of compliments. What a great session. We had people joining from all over the world, so that's amazing. But yeah, thank you. Thank you very much, Liam. I'm just going to bring up our Reactor slide. So just for everyone, this series will be available to watch on replay on the Reactor YouTube channel. You can find that under the playlist DevOps and Developer Tools, so basically all these 3 episodes will be uploaded on that playlist and will be available to view forever, basically. Join our meetup. Please do join our meetup for to know all about our upcoming events. Follow our Twitter, again, to know all about our upcoming events. We do have the Azure AI series starting from next week, from the 28th, which will be run by all female tech experts, so you don't want to miss that. And we also have our Reactor Community Spotlight event, where we will be interviewing one of our community leaders, and that will be a great opportunity for you to learn more about what they do, how they got into tech. So please do join us for that. And all these all these events are available on our meetup. So please do follow our meetup and you'll get information to everything. But that's it from me. Thank you so much, Liam, for an amazing session. And thank you everyone for joining.
Thank you very much. It's been great. And I'll see you all in the next one.
Great. Thanks.
Bye-bye.